And this video is for the slope of a line lesson. After completing the Desmos activity, you should have some familiarity with what is meant by the slope of a line. The slope of a line tells us a few things about the line. It tells us the steepness and in which direction the line is going. Let's answer a few questions before we get started. Phil and Clark received donations for each mile they run for a charity race. If Clark put $15 of his own money towards his total, how does that appear in the graph? You can see that at Phil, he starts with $0, while Clark starts at that $15 mark. Who has the higher donation amount at 1 mile? It appears that Phil has somewhere around $8 at 1 mile, while Clark has 20, so that would be Clark. And at 5 miles, Phil is at about 37 or so, while Clark is still above him at $40 approximately. And although he is still in the lead at 5 miles, why is Clark's lead now shrinking? If you notice, although he started with more money, his line is increasing more slowly than Phil's, and you can tell that by looking at how steep the line is. And at how many miles will Phil have more in donations than Clark? It appears as though at about 7 miles they are pretty much equal. So after 7 miles, at about 8 miles, Phil will now have more than Clark. So let's just talk about what is slope. The slope of a line is a ratio that represents how steep the line is, whether the line is increasing or decreasing from left to right. And then we always write our slope as a fraction in simplest form. How we calculate the slope is by finding the change in the y values, which if you look at this example I have here, the change in the y values, if we remember, the y-axis is the vertical axis. So when we are looking at a graph or we're looking at points, we want to take the y values first and find the change between those y values. So here we have -1 and 3. From -1 all the way up to a +3, that needs to climb a +4 to get there. You can do that by calculating it, or you can do it by counting spaces. 1, 2, 3, 4. And then that is going to go on top of our fraction, and then the change in the x values is going to go along the bottom. So again, we can look at our x values, which are -2 as our starting value, up to +4 as our ending value. And notice I'm going from left to right because that's how we read. So from -2 to +4, that's a big jump of 6. So we can calculate it that way, or we can again count the spaces on the graph, starting here, counting over 1, 2, 3, 4, 5, and 6. And that is our x change between the two x coordinates. And then 4/6 can simplify to 2/3, which gives us our slope of that line. So again, it's a ratio, and the ratio is the change in the y values over the change in the x values. So we are looking at a comparison of two at y values and a comparison of two x values. Whether we do that visually on the graph or numerically, there's lots of different ways we can calculate this. So let's try some examples. Here are those directions that I just gave you for doing it on a graph. So we're going to start here on the left, and we're going to work our way to the right. So from left to right, this graph is going down. So when we start here at that first point, we're going to count 1, 2, 3 spaces down. And since it's going down, that's going to be a change of -3. That's going to go on top. And then we need to go over 1 space along the x-axis. That's going to go on the bottom for a change of -3/1, or just -3. Now you might have noticed that there are other points on the graph. I chose to stop at this next one. I could have continued on to the last one if I wanted. Let me show you how that would slightly change our work but keep the same answer. So if I started here but went all the way down to here, I'm going to go 1, 2, 3, 4, 5, 6 spaces down. So instead of a -3, that would give us a -6 in the y change, because again, the y values go up and down, and then a 1, 2 on the x-axis. So -6/2, but that still simplifies to -3. So as you can see, we can get the same answer, and the reason we get the same answer is because on a line, this change between all the points is consistent as long as the line is straight. Let's try another example. We're going to start here at this point on the left and work our way to the point on the right. We're going to count up or down 1, 2, 3 spaces along the y-axis, so that's going to go on top. And then we're going to count over 1, 2, 3, 4, 5, 6 along the x-axis. That's going to go on the bottom. 3/6 is 1/2 in simplest form. Notice that when I go up, that's going to give me a positive change. Down is going to give me a negative change. When I go to the right, that's a positive change. And if I go from left to right on the graph, I should always be going in that direction, but I can also go to the left, and that would be a negative direction. If I accidentally went the opposite direction when I'm calculating my slope, let's say I started from the right and went to the left, I can still get the correct answer. I would go 1, 2, 3 spaces down, which would be a -3, and 1, 2, 3, 4, 5, 6 spaces to the left, which would be a -6. So when I write my -3/6, we see that the two negatives would then cancel and keep our answer at a positive 1/2. So we still get the same answer. These next examples, you notice we don't have a picture. So we have to just recall that our x's are the first coordinates and that our y's are the second coordinate. You're welcome to graph these and then do the same thing we just did, but that can take time. So instead, what we can do is just look at the values and calculate the difference between the two. So from 3 to 5, notice I'm starting with the y values because that's what goes on top of my ratio. From 3 to 5 is an increase of 2. And from 4 to 8 is an increase of 4, so that is my slope of 1/2. For the second example, my y values go from 0 up to +2, so that's a change of 2. My x values are going to go from 8 down to -3, so that's a drop of 5. That cannot be simplified, so I leave my answer as 2/-5. For our last example, like this, our y values go from a +10 all the way down to a -1. That is a drop of 11. Our x goes from a -2 all the way down to a -12, which is a drop of 10. So that's a -11 over a -10, which gives us a final answer of +11/10 because the two negatives will cancel each other out. Moving along to the next couple examples, these ones are similar to the first ones that we did, but these ones now have units along the graph. So when we deal with units, we have to pay attention to a couple things. What are the measurements? And then what are the axes being counted by? Notice they're not counting by ones as our first few examples were. So when we identify points on the graph to use, and when we're counting spaces, we can't simply count spaces anymore. We have to count by what the axes are counting by. So for example, first start by identifying 2 points on the line, as I did. Then I'm going to count, this is 2 spaces up, but it is going from a +10 to a +20. So that is actually an increase of 10, not 2. And then 1, 2, 3 spaces to the right, but it goes from a 5 to a 10. So that is going up by 5. The y change is our 10, so that goes on top, and that is quarts of water needed for every 5 days. Now we want to simplify that to a unit rate of 2 quarts per day as our final answer. noticing that I'm including units here because there are units on my graph. Let's try another example, starting out by putting points on the graph, and you are free to pick whatever points you want because, as I said earlier, the line is consistently decreasing and increasing at the same rate as long as it's straight. So starting here at 40, I'm going to drop to 30. So that's a drop of 10. So that's negative 10. And then from this to here, that's only one space, but it goes from 5 up to 10. So that is up by 5. So this one is a slope of negative 10. This is ounces of raisins for every 5 ounces of peanuts. So what's happening here is they're making a trail mix or something along those lines. So it says for every 2 ounces of raisins we do not put in, you need an extra ounce of peanuts. Or that's how they at least make their trail mix. Seems strange to make it negative, but it's saying for every 2 ounces of raisins you don't put in, you need 1 ounce of peanut to fill that bag. All right, in our final examples, again, we don't have any pictures here. We have some tables. We need to recall a few things. We need to recall that our x values come first and our y values come second, so that when we put our ratio as the change in y over change in x, we're looking at the right values. So what are our change in amongst our y values? So from 12 to 24, from 24 to 36, and from 36 to 48, those each go up by $12. So we have a y change of $12 for every 5 items. So the x goes up by 5 each time. So our slope here is $12 per every 5 items, but we like to write it as a single unit rate. So that's $2.40 per item. I know earlier I said keep it as a fraction in simplest form. 12 over 5 technically is in simplest form, but for a problem like this, it is probably more likely to want a unit rate with money as a decimal, so $2.40 per item. And for our final example, we want to recall that x is the value row on top, where y is the row on the bottom. So when we calculate our change, we want to do the y's first. So from 36 down to 38 down to 26, 26 down to 14, 14 down to 2, this is going down by 12 gallons as the time is increasing by 1 minute. So this is negative 12 gallons, that's our y change, per minute. Let's say that's the draining of the bathtub, is how fast the bathtub drains. As a final challenge, try drawing any line with a slope of 1/3. To do that, you would need to pick any starting value wherever you would like on the graph. And then to draw a line with a slope of 1/3, that means that our y change is 1 and our x change is 3. So that's going to go up by a positive 1 and over by a positive 3 along the x-axis. Up 1 over 3. You can repeat that over and over again like steps to make sure that your line is nice and straight. You can even go backwards and go down and to the left. But there is a line with a slope of 1/3. It doesn't matter where you started it because I didn't get you a starting value, but it should be that steepness wherever on the graph you drew it.